Rocking. Good morning, everyone. Great to see you all here just before lunch on this session about the Swiss Army knife of cloud-native networking. My name is Raymond de Jong. I'm Dutch, but I actually live since a few months in Switzerland, in a nice little town called Sattel in Switzerland. And I'm close to actually the company who makes amazing Swiss Army knives, Victorinox. And I thought this would be a good theme to talk about what Cilium is about, which is capable to do today. I'm also known by my colleagues, especially the Swiss colleagues, as being a part-time ambassador for Swiss tourism because I absolutely love this country. I like skiing, I like cycling, hiking, nature, everything is amazing. So I'm a proud ambassador of Switzerland. So today I'm going to talk about Cilium specifically, but Isovena, the company behind Cilium, Tetragon, also contributing in eBPF, is now part of Cisco. My role is Field CTO EMEA for Isovalent at Cisco, and we obviously also provide support in an enterprise release and also provide Tetragon Enterprise. But today we're going to talk about Cilium open source. How many of you know about eBPF? Quite a lot. Oh, wow. So I actually don't need to do a lot of introductions. But for those who don't know, eBPF allows us to run stuff in the kernel without changing the kernel. And this means that we can make it extensible without changing the kernel itself. And that's a very secure way of making new things or reinventing networking using eBPF instead of legacy technology. For today's talk, what this means is all related to kernel events related to networking events, sending a packet, receiving a packet, filtering a packet, and so forth. And that's where we use eBPF for as a hook point on syscalls to execute code at a blasting quick speed and security. Cilium runs eBPF under the hood. Think of Cilium as an amazing engine. An amazing car, and eBPF is actually the engine in that car powering Cilium. But you don't have to know eBPF by heart. Cilium provides you with the right configuration, the values you can use using the CLI or using a Helm values file to use the features and capabilities eBPF bring. Now, obviously, we need a Swiss Army knife in this session because that's the title of it. So in this session, I'm going to cover a lot of tools Cilium provides as the Swiss Army knife. So we're going to talk a bit about BGP, about layer 2 announcements if you are not able to run BGP, using the built-in load balancing capabilities in combination with the LB IPAM module, and finally, how Gateway API can also be extending that capabilities as well. If I have enough time, and I'm sure I will run a nice little demo putting this all together. So let's start with BGP. So Cilium already supported BGP for a long time, but we started with implementing Metal LB, and we wanted to remove this dependency, so we developed our own BGP control plane. This is actually running really well. It's running on Go BGP, but now we're extending those capabilities with the BGP control plane version 2, which will be released in Cilium 1.16. What I'm going to show today is actually what's coming in 1.16, and that's about to be released in July timeframe. So typical use case is obviously to be able to attract ingress traffic, to configure how egress traffic should be dealt with. Also, automation of the network. You don't have to configure anything on the external network. Routes are being received automatically. Also, availability is a common use case. You can have multiple nodes taking part in the routing topology using BGP. Also, recoverability is there. If a node fails, other nodes can receive traffic and advertise routes as such. And you can do a lot of traffic engineering. Some challenges here are obviously multi-tenancy, if you want to use different IP addresses and such. Partly it's also about the demo I will show later. Security, how to secure those connections and sessions, and optimizing traffic, especially if you're running on-prem data center networking, maybe a spine leaf topology. You need to consider how to configure routing in and out your Kubernetes clusters, and what's the optimal path going in and out your cluster. So for those who don't know BGP, I will try to summarize a bit from a networking background what BGP actually is. So a quick introduction, it's a dynamic routing protocol running on TCP port 179. And it's used to have routers being neighbors and exchange routing information. So one router can talk to another router and say, hey, I'm this router, I have this autonomous system number, and this contains these routes. For example, 10.10.00 / 16. And the other routes say, thank you, I'm router B, my autonomous system number is 165.0.0.0, and I have the routes 10.20.00 / 16. And if you want to reach that network, send it to me and I'll take care of that traffic. Basically, the internet is built on this concept as well. So if you have a public IP that's being run by a service provider using BGP and routed on the internet as such. And a given router can have multiple routing sessions, and this you can optimize paths and so forth. Like I said, Cilium fully supports BGP. We're extending capabilities in Cilium using the Cilium BGP control plane. This allows you to advertise external IPs, load balancer IPs, pod IPs. We recently added capabilities to also have pod pools to be working with the load balancer IPAM functionality to advertise those IPs. But also like really hardcore BGP features such as the MD5 passwords for the session between routers, graceful restart for having high available control plane in terms of BGP, not shutting down the routing session, removing routes at a router while, for example, one of the Cilium nodes is restarting, and so forth. Also operational tooling using the CLI from Cilium, the Cilium command line interface. So these are new resources coming in upcoming 1.16 release. We improved the BGP control plane. And I want to introduce the BGP cluster config CRD, which allows you to select nodes where this BGP router will run. You would configure an autonomous system number, and you will specify one or more peers. In this case, this is an IPv6 peer, but it can also obviously support IPv4 addresses. Note this peer config reference in this CRD because this is introducing another resource, which is called the Cilium BGP peer config CRD. This is a CRD you should use to configure common parameters, such as the graceful restart, such as the MD5 password, or the address families you need to set. These are typically used across multiple routers the same way because you're peering with an external network and external routers which are configured in a similar way. We do support IPv4 and IPv6 address families and unicast as secondary address families. Then I want to highlight this match label advertise because this will select another resource you can use for the specific peering. So imagine you have two routers, they share the same peering CRD, they have the same configuration, and then you want to specify what you're actually going to advertise. So in this example, you use the Cilium BGP advertisement CRD to specify, based on its labels, which is referenced by the Cilium BGP peer config, what kind of services or pod IPs you want to expose. So in this case, I want to advertise the cluster IP addresses, the external IP addresses, and the load balancer IP addresses. And I also use a selector for matching types of load balancer with specific labels. In this case, BGP as a key and the value blue. And we'll dive in the demo later on how that actually works. So this covers BGP briefly. If you are not able to run BGP, fear not, we also have layer 2 announcement support. And this is typically used in smaller environments or testing environments where you don't want to set up the external network for all this complex BGP routing. Maybe you don't want to involve the networking team right away when you're starting a lab session or a test environment, or you don't even have BGP support. That can also be the case. What this does is basically you can expose you can expose load balancer IPs. And if someone on the external network wants to reach that IP, it will rely on ARP requests. So who has this IP. And in this case, one specific node can respond, I have this IP, this virtual IP of this load balancer. And the network learns automatically that it connects to that node to reach that given service. Obviously, multiple nodes will have this virtual IP, but one will only respond. That's the way ARP works. And that also means that this specific node will be the north-south load balancer for this specific traffic. If a given node fails, obviously you rely on ARP timeouts for another node to be able to pick up that traffic. So it's not as robust and high available and recoverable as BGP is, but in some cases good enough. How this works is another CRD, the Cilium Layer 2 Announcement Policy CRD, where you specify which nodes should participate using this virtual IP. In this case, we are actually doing a match expression to only select nodes which are not part of the control plane nodes. So all other nodes can participate. You specify, for example, an interface it should listen on for ARP requests for specific IPs. And then you can expose, for example, external IPs or load balancer IPs by giving a value of true. Moving on to LB IPAM, and this goes really nicely together with both of these capabilities. Load balancer IP address management feature is an operator feature which allows you to define multiple IP pools for maybe different services. In this case, and for this demo, we're using this to show multiple IP pools where each tenant gets a different IP pool. And this allows you to create different IP addresses for example, a load balancer to attract traffic for your cluster. But on the external network, it allows you to do traffic engineering using that CIDR, for example. This is a very flexible model. You can use selectors, namespaces as selectors as well. And we also work with multi-pool pod IPs. So if you're using multiple interfaces on a given pod, we can also use that together with this capability to assign different IP addresses to different resources. Finally, using Gateway API, we can actually do more with our north-south load balancer. And this, I will show later how this works together with BGP. But to introduce Gateway API, obviously this is a service role-oriented model which allows different personas interact with different resources. I sometimes call it the Ingress version 2. Allows you to do a lot of layer 7 routing, load balancing capabilities. And typically you see, for example, an infrastructure provider such as Google or AWS providing a gateway class, whereas the cluster operator would configure one or multiple gateways, and given teams, application teams or tenants would use HTTP route resources or TCP route resources to define how traffic on layer 7, for example, should be dealt with and to which services that should be forwarded. Cilium fully supports Gateway API. I think Gateway API is at the moment at 1.0 release, and Cilium fully supports that today. And I think for common use cases for Gateway API, obviously the traffic management, canary rollouts, load balancing based on weights, A/B testing, for scalability, and also getting layer 7 metrics, also known as golden signals. Using Cilium, you can also use Grafana dashboards to get those metrics, such as duration, response codes, and so forth, to monitor the health of your application running on Kubernetes. Now, today we're going to specifically look at a new capability added in Gateway API. This is, as far as I know today, in the experimental channel of Gateway API. So if you want to use this, you need to use the experimental channel CRDs. And what this does, it allows you to specify an infrastructure field. And this is super useful because this allows you to propagate labels or annotation to the load balancer a Gateway API configures automatically to be propagated on that object. So in cloud, you can specify, for example, if you're running GKE, you can specify if it should run an internal load balancer or an external load balancer. And that behaves different, obviously, in Google Cloud. And for AWS, it's different as well. For on-prem, this allows us to propagate these labels to the load balancer objects, which then nicely hooks into, for example, the load balancer IPAM capabilities. So you can do this traffic engineering configuration there. So as you can see here, we just add a label color blue, but on the created load balancer service, this will also be created automatically. And this brings me to the demo, and I have plenty of time to actually show that. So let's bring this all together in this Swiss Army knife, use all the tools we have, and see how that works. So in the demo, I'm doing the following user stories, right? As a platform engineer, I want to support a platform which allows multiple tenants or teams to work on independently, where I want to provide separation of ingress traffic, but also using microsegmentation, using network policies. I want to use Gateway API to provide layer 7 routing and filtering capabilities. This allows my application team to use HTTP routes to define what traffic goes to what service. And I want to be able to advertise load balancer IPs to the external network using BGP and bring this all together. So for this demo, I'm using a Container Labs environment. This allows me to simulate in a VM virtual routers running FRR. And in this case, I have a kind cluster consisting of 4 nodes doing a 2-rack model where 2 nodes are in rack 0 and the other 2 are in rack 1. And this means I need to define my Cilium BGP peering policy specifically for those nodes. On a namespace level, what I'm going to show is that I've created 3 namespaces, let's say a blue team, a red team, and a yellow team. Each of them creates a gateway. Each of them runs an application. But what's important here is that we create a load balancer automatically because we use Gateway API. But this load balancer should advertise IP specific for this given tenant. And this allows a networking engineer to configure routing for the given tenant on the external network as well, to allow traffic engineering. All right, let me switch to the demo environments. I think it should be readable in the back. If not, please raise your hand. I think we should be fine. So to get started with this, first of all, you need to install the Gateway API CRD, so in this case, the experimental ones. And then you can install Cilium. So in this case, I've installed Cilium 1.16, the pre-release. And you need to specify specific values to use this. So first of all, allow the BGP control plane to be enabled. That needs to be true. I want to use Gateway API, so Cilium will be a gateway class for Gateway API, enabled true. And what's also required here is the kube proxy replacement being set to true. This is related to Gateway API. Then I'm basically ready to run these capabilities and configure the workloads which I need. So I already have namespaces. So here you can see I've prepared the namespaces. For sake of time, I already deployed IP pools as well. Let me quickly show you. So I created an IP pool for the blue tenant where I specify a CIDR block, in this case 20.0.10/24. And I do a service selector based on a match expressions. In this case, all load balancers with color blue. For the red, I just selected the red label by using a match label selector. And for yellow, just to show you as an example, I match on the namespace name. That's also possible. So it's a fairly flexible selection model. So that's already prepared for the sake of time. And next is looking at this Cilium BGP cluster config. If you remember the diagram, I want to simulate this 2-rack model, right? Which is fairly typical in data center deployments. So 2 nodes in rack 0, 2 nodes in rack 1. So I have 2 Cilium BGP cluster configs configured, or prepared actually. One for rack 0, I select nodes, matching labels, rack 0, and I create a BGP instance, in this case, name and an autonomous system number, 65010. And then I specify peers. And this is actually the upstream router. In this case, with the same autonomous system on this IP address and I reference the peer config, which I will show in a minute. Similarly, for the rec1 nodes, I select nodes matching label rec1, and in this case, it has a different autonomous system peering with a different router with the same autonomous system upstream with a different IP, but sharing the same peer config. On the peer config, this is fairly straightforward. In this case, I just enabled graceful restart with this setting, and I'm specifying the address families, in this case IPv4, and I will advertise any BGP advertisement CRD matching the labels BGP. Moving to the BGP advertisements CRD, we can see we're matching on these labels. This is important, otherwise the peer config will not select it. And then I have a number of advertisements. Because I have 3 tenants, I create 3 advertisements. For load balancer IPs, matching the blue tenants and the red tenants, and one for the yellow tenants. So if I use the Cilium CLI now, if I do Cilium BGP peers, I then don't get any response. There are no peers yet. We didn't yet apply this configuration. And if I do show neighbors command, so this is actually a shortcut to, this is why. I'm now actually doing a short SSH session in this of FRR routers to see the BGP state for those. And as you can see, it's active. That means it's not yet established. The configured routers on the networking side are not up and running, which in this case are the Cilium nodes. Let's apply the CRD. So I have created a little script to quickly do 3 commands in one. So now I'm applying the Cilium BGP cluster config, the Cilium BGP peer config, and the advertisement config I just shown. And given the IP pools are already up and running, the operator will now select an IP address for a given tenant. So if I do get services -all, I should see the tenant red and the tenant yellow because they are already configured, and the IP load balancer IPAM feature selects specific IP addresses for that specific gateway. Going back to this blue IP pool, we need to configure a gateway for this blue tenant, and that should select this IP. So for that, I prepared a gateway blue. And remember, I'm using this infrastructure label to make sure that the load balancer which is being created automatically gets that IP. So let me do that. Gateway blue, that's being created. And now we should see somewhere, yes, here. So now the tenant blue gets a load balancer created automatically by Cilium for that gateway resource with 20.0.10.1. So now this tenant has a IP available as well. And if we now do, for example, Cilium BGP peers, we can now see that all the nodes in my cluster actually established a BGP session with the upstream routers, and they are advertising, in this case, 4 prefixes. And on the router side, I should see routes as well. Show BGP. So let me scroll, find an example. Yeah, so here you can see the router now has learned a route to, for example, one of the other tenants for 40.0.10.1. So this brings nicely together all these capabilities Cilium has as a Swiss Army knife for your environment to configure and to do this engineering of multi-tenancy, BGP networking, and such. Given the time, this concludes my demo for now. You can try this out yourself as well. We have amazing labs based on Instruct, self-guided, self-explanatory. You can actually explore these capabilities as well. And this will also be documented on the Cilium IO website. We are available at the booth, so if you want to know more about this, I'm happy to answer any questions. Also, any Swiss tourism-related ones, happy to help you there as well. With that, I'm happy to take any questions.
Thank you very much, Ray. Are there any questions?
Oh. Was it that clear, or? Cool.
You are right. Thanks for the presentation. You are right that the BGP mode is much more powerful, but there are cases where you cannot or like don't want to use BGP mode, so you go with a layer 2 mode. Have you considered also instead of, in addition to IP address management, to use DHCP to assign IPs for load balancer services? I think some of software load balancers support this.
Okay. I'm not aware of such a roadmap item. I can check that offline, but I never heard that requirement that much in the field, I would say. So at the moment, I'm aware that it's not being considered as such. Any other questions?
So it was a really nice presentation. So I have worked with eBPF, and I don't have much experience with Cilium at all. I'm going to be honest. But eBPF I know it's a kernel probing technology that you can just add probes and look into the system calls and look at the parameters and arguments. I'm just curious, like, how does Cilium uses it? If you can just give a brief overview about it.
I think the best example is the Q-proxy replacement, the east-west load balancing for services in a given cluster. With other legacy CNIs, you would typically leverage under the hood IP tables or IPVS technology, which by itself is fine technology, but is not really fit for the scale and churn Kubernetes brings. What happens under the hood using IP tables is a chain of tables, and each endpoint for a given service, so each pod or each service you create, will be an entry in one or multiple tables in IP tables. In small clusters, that's fine. You will notice nothing. But once your cluster grows bigger, you have more workloads, you will see some latency when you try to do, for example, you're scaling out an application or you have churn. Then it will not be able to keep up with the updates because every time the full IP table needs to be updated. So, for example, how we use eBPF is for this load balancing use case, we keep hash tables of the BPF maps, basically, of those endpoints. Each endpoint is an atomic change, right? So if you add 10 pods for a given service, we just add 10 pods in that map. And eBPF, when it needs to make a decision where to load balance traffic to, can quickly query this BPF map, what to route traffic to. So it's very, very responsive and quick, if that helps.
Okay.
Does that answer your question? Does that make sense?
Yeah, I mean, so it's just going back to the roots of packet filtering of BPF.
Technically, yeah, that's one example. But we use it as well for IPsec, right?
Yeah.
Transparent encryption, enabling setting up an encrypted channel between nodes. So
Yeah.
that's also an eBPF program we use.
Okay, now it makes sense. Thank you.
Welcome. Any other questions?
Then thank you very much, Ray, for your awesome talk.
Thanks.